Hello and welcome. My name is Amir and today we are going to solve the puzzle on day 6 of the Advent of Code 2023. So let's jump right into the puzzle. So here's the story. I will skip that. We have an input like this and they say that there is a toy boat and we hold down the button that charges the boat and release the button will allow it to move. I'll make it a little bit bigger. Boats move faster if their button was held longer, but the time spent holding the button counts against the total race time. So it says that the first race lasts 7 milliseconds, this number, and the record distance for this race is 9 millimeters, this much. The second is 15 and the record is 40, and then 30 and 200. So your toy boat has a starting speed of 0, and then for each millisecond we get 1 millimeter per second. So if we don't hold it, the speed is 0 and we don't go any much ahead. If we hold button for 1 millisecond, then we have the speed of 1 and we will travel 6 millimeters with the speed of 1 because the whole race is 7 and we hold the button for 1, so we missed 1 milliseconds, but we have 6 milliseconds, and at every millisecond we go 1 millimeter per millisecond, so the speed will be 6. We hold the button for 2, it will give us the speed of 2, and we have 5 milliseconds to move, so with the speed of 2 and then 5 milliseconds we get to 10, and so forth and so on. Now, using all of these calculations, we can see that we will beat the record if we hold the button for 2, 3, 4 or 5 milliseconds. Either of these will get us a number which is greater than the record, which is 9. To see how much margin of error we have, we need to determine the ways we can beat the record in each race. So we multiply them to get 288, so we get the 288 as the result. So the easy way to do this, or the naive way, is just have a for loop and count from 0 to 7 and then do the calculation. But we need to come up with a better idea. Let me grab a sketch pad. So if we grab this, make this bigger. So with 7 we go 0. With 6 we go 1. With 5 we go 2. With 4 we go 3, and so forth. So it looks like we have a formula like, we grab another one here, x times 7 minus x, for x going from 0 to 7. So in other words, this is like 7x minus x squared, and we want this formula to be greater than 9. So to solve this, we can set this to 9 and then bring 9 to here, and it will be a quadratic formula and we can solve it based on that. So let me draw this for you so you understand it better. So here we have this formula. Make it a little bit smaller and like this. So we want the values for this curve that are greater than 9. So let me make it a bit bigger here. This is 9, so we want these values. In other words, I want this. When I subtract 9 from it, to get the values that are greater than 0, so which is 2, 3, 4, and 5. So I can solve this and get two roots, which will be the point that we have here and the point that we have here, and I will subtract them from each other to get the number of points that lay between the roots, and that would be my answer. We'll grab the input from here. So this is the input part 1. So first I need to grab the times. So this is the input at index 0. I will split by space and I will throw all the empty value in the between and also this one, and then in the end I will convert these values that remain into the number. Now this will give me not a number for this one, so I will skip that one and keep the rest as time. I would do the same for distances, and this is input at index 1. Log them, for example distance. I get the values right. I can say that the win value is the time that will be reduced. I'm using the reduce because I'm going to perform a function on all of these values and I want to multiply them all together. So I would use the time reduce to do it in one place. The accumulator and the lap and the index. I'm using the index because I'm performing the action on this one, but at the same time I need the same index from this one as well. So using I can get this value. I would first get the delta, which is this formula that we have here, which is this part, is square root of b2 minus 4ac. Now I have two roots, root 1 and root 2. Root 1 will be this plus delta over 2a, and root 2 will be this minus delta over 2a. Now I'm getting these values, this root and this root. I need to find which one is the minimum and which one is the maximum between the roots, and then I will count the numbers in between. But these values can have floating point. I want to skip that part, so I will put them inside some flooring function. For this one I would use the floor, and for this one I would use the ceiling, and then in the end I would subtract these two values from each other. So, and I need to say this one is minus 1 as well, or I could provide minus 1 here as well. So this is working like this. This is root 1, I would go 1 to the left, and this is root 2, I would go to 6, and then I would subtract 1. So I would land here, and for this one I would land here at 1. So I'm counting from 1 to 5, which is 4. And in the end we just multiply the ACC by that value. We need to say it starts at 1, and then we need to return the ACC, and here we can just log the win and see what we get. 288, which is I think the correct answer. So going here, this is 288, which is correct. Let's get the input, paste, save, and this value I would go here. Correct. Let's go to part 2. So it means that this value is like 71530. So this is a huge number. So we need to resolve the puzzle with this number, and it's only one number. So I need to change a few things. So here time now is the input, and then I need to check that if that is a number as well, and then I would join them. So this will be the time, and let me say let time, and then in the end I would convert the time to the number. I would do the same for this as well. So now if I skip this part and log, yeah, this shouldn't be an array. This is just a number, just a value here. So now I get two big values. This should be 1, but this is the input. So now I'm getting the correct input. I would need this part here. So the delta is the same, and here we don't have lap, this is only time. The same is here, and we don't have this at index I, there is only one distance, and the rest should be fine. We just need to return the count. So this is correct. Let's get the puzzle input. Go back, go here, paste, and we get to this number. Let's go here, and correct. So yeah, this was the solution for puzzle day 6. I hope you enjoyed the video, and see you in the next one.